Chapter 12 Programming Languages. There are hundreds of programming languages, and programmers use different languages for different types of text. Languages like JavaScript, PHP, and Python are used to make web pages, documents that can be displayed in a web browser, like Chrome, Safari, or Firefox. A collection of web pages is called a website. Mobile applications are made with the programming languages Swift, Java, C, and others. Mobile applications are types of software designed to run on mobile devices like cell phones and tablets. Using programming languages. Since each programming language has different strengths, for example, some are faster, others are easier to write, or some show graphics better, programmers may use several languages for large projects. For example, Facebook uses Python, JavaScript, PHP, and others. YouTube uses Python, JavaScript, C++, and others. Twitter uses JavaScript, C++, Ruby, and others. All three websites use JavaScript. That's because JavaScript, along with HTML and CSS, is primarily a front-end language, which means it is used to make the part of a website that can be viewed on a screen. Websites like Facebook, YouTube, and Twitter also store tons of information, posts, comments, profile pictures, videos, etc. This means they need another type of programming language, a backend type, to organize and connect all the extra information to the front end. Different backend languages are used for different reasons. For example, C++ follows instructions faster than other programming languages, but it's harder to write. So a company might start by writing their product in an easier language like Python and then go back and replace parts of the product with C++ to increase the speed at which it processes information. No computer programmer knows every programming language, just like no one knows every spoken language. However, it is useful to know a few programming languages so that, for example, you can combine a language that is great for graphics with a language that is great for processing large amounts of code. How computers read code? Code equals language a computer understands. Binary. Computers process information using electrical circuits, which is a part or collection of parts through which electricity is carried that can turn on and off. Computer scientists use the digits 1 and 0 to stand for on and off. The ones and zeros are a type of encoding called binary or machine code. A binary digit can be either 0 or 1. In binary, ones and zeros are often used, but you can also represent binary with on and off or true and false. All words, numbers, letters, symbols, images, videos, programs, emojis, and music can be represented in binary. Binary is how computers talk and represent information. 1 is on and 0 is off. Machine code, the most basic language that all programming languages are turned into before a computer runs them. The CPU of a computer can only read instructions written in machine code. So after a human enters a program into a computer program then turns it into binary machine code. The process of changing a program into machine code is called compiling, which means translating a programming language into machine code. No matter how many different programming languages are used to write the phrase hello world, the machine code for each version looks the same. Binary equals machine code. A compiler changes instructions from the programming language into machine code. Before the first compiler was invented, programmers had to write their programs in a language close to machine code. In 1952, Grace Hopper wrote the first compiler program. Her compiler helped programmers spend less time writing out machine code and more time creating programs. Representing numbers using binary. Binary is another way of using numbers to count or to represent numbers. Binary is sometimes referred to as base 2 because it uses 2 digits, 0 and 1, while our usual way of counting is called base 10 because it uses 10 digits. The bi in binary means 2. Even though binary uses only 2 digits, it can still be used to represent every number value that base 10 can. In base 10, each place is 10 times the value of the place to its right. As numbers get larger, we add digits to the next place value to the left. For example, the number 237 means 237. Each digit corresponds to a value that is based on the place of the digit in the number. In binary, numbers increase in value 2 times as we double multiply by 2 the value of each new place from right to left. Digits in base 2 binary have the place values of 1, 2, 4, 8, 16, 32, 64, and so on, doubling each time. Binary place values from right to left. Each place is double the value of the previous one. To represent the number in binary, the number 1 in binary, write 1 on the ones place. There is no 2 digit in binary. To write the number 2, put a 0 in the ones placeholder, then move to the left and put a 1 in the twos place. 0 is in the ones place, so its value is 0 into 1 or 0. 1 is in the twos place, so its value is 1 into 2 or 2. When you add together the two values, 0 plus 2, you get 2. You can use basic addition to figure out binary values. Another way to think of binary digits is how computers do, as on and off. For example, if we had 8 light bulbs lined up in a row to represent 8 place values in base 2, we could use them to represent a number in binary by turning each light bulb on and off. On or off, you can represent 237 using a row of 8 light bulbs. Each light bulb that is on represents 1, and each light bulb that is off represents 0 value in the placeholder. The sum of the place values for the light bulbs that are on is 237, 128 plus 64 plus 32 plus 8 plus 4 plus 1. Representing letters in binary. At first, computers were used just to make mathematical calculations. Later, a way to represent letters and symbols in binary was developed. The American Standard Code for Information Interchange (ASCII) assigned each letter of the alphabet and symbol its own binary code. Each letter was assigned a number, which was then encoded into binary. For example, the capital letter A is assigned the number 65, which in binary is written 0100000001. Although the number 65 and the letter A share the exact same binary code, the program tells the computer if it should interpret the binary as letters or numbers. Bits and bytes. Terms like 16 gigabytes of memory or 1 terabyte hard drive are used when talking about computer storage. These terms represent quantities of binary digits. A bit, which is short for binary digit, is the smallest unit of storage. It represents 1 digit, 1 or 0. The next greater measurement is a byte, which represents 8 bits. For example, 01010101 is 1 byte. There are 8 digits. Small letter b equal bit, capital letter B equal byte. The largest number you can represent with 1 byte is 11111111, which in base 10 is 255. That's why RGB color values run from 0 to 255 because those are the numbers you can represent with 1 byte. Larger quantities of bytes can be represented using a prefix kilobyte KB. About 1000 bytes, a 5-page Word document around 100 kilobyte, megabyte, MB. About 1 million bytes, audio files are several megabyte, gigabyte, GB. About 1 billion bytes, HD movies are a few gigabyte, terabyte, TB. About 1 trillion bytes, some new hard drives hold around 1 to 3 terabyte. The Hubble Space Telescope sends 10 terabyte of data to Earth every year. The Hubble Space Telescope was the first major telescope to be placed in space, launched into Earth's orbit in 1990. It is one of the largest telescopes ever made. Its purpose is to allow scientists to observe distant stars and planets. Creating algorithms. Before typing out a program, programmers first come up with an algorithm or list of steps that will be used in the code. They often use pseudocode, pronouns pseudo, and flowcharts, which is a diagram that outlines the steps in a process to design or plan algorithms before they begin programming. Pseudocode. Pseudocode is written in a style or format that's similar to the programming language a programmer is going to use. There are no rules on how to write pseudocode, but it's meant to be read by humans, not a computer. Most programmers format their pseudocode so that each line represents a line of real code in their final program. The pseudocode doesn't have to be perfect. It should just give an idea of what the final program may look like. Coding without a plan is like building a house without a blueprint. Flowcharts. Flowcharts help programmers visualize the steps in an algorithm, just like making an outline before writing an essay. Flowcharts help organize ideas, and they use specific symbols to represent different parts of an algorithm. Each symbol in a flowchart has a meaning. Over symbol means the beginning or end of the program. Parallelogram symbol means an output operation in flowchart. Rectangle symbol means a process to be carried out, an addition, subtraction, division, etc. in flowchart. Diamond symbol means a decision or branch to be made. The program should continue along one of the two routes in flowchart. Hybrid symbol means an output operation in flowchart. Flowline symbol means the direction of flow in the program in flowchart. If you wanted to write an algorithm to check if today is your friend's birthday, the flowchart might look like this. Look up today's date. Is today's month and day the same as your friend's birthday? In left, true. Say, don't forget to wish your friend a happy birthday today. In right, false. Say, no reminders today. It might look like this in pseudocode. Look up today's date. If the month and day of your friend's birth date are the same as today's date, then say, don't forget to wish your friend a happy birthday today. As say, no reminders today.